Hello guys, can you hear me?
Yes,
Yes,
doctor.
doctor.
How are you guys? It's been a long time. Everybody okay?
Okay, I'm good. Alhamdulillah.
Good. I'm good. Thank you very much, Sharifa. Okay, so you guys have already watched the video? Okay, can you see my screen?
Yes, doctor.
Okay, good. Before I start my class today, I would like to inform you that, okay, next week, first of all, next week is the semester break or not yet?
I think that's in 2 weeks. I believe so.
Is it next week?
No, no, like next of next week.
Okay, they follow. All right. So next week, we are not going to have our first test yet. I prefer to, delay it to after the semester break because next week I'm going to make it up for the holidays that we had last week. So we are going to discuss actually two topics next week. All right. So the first test will be after the semester break. Is that okay? Is that okay, doctor? Guys, all right. And for the test is going to be for the first seven topics, okay, including this one is the fifth computational thinking is number five, and we still have two more topics that we are going to discuss next week, and then all these seven, let's say, chapters are going to be included in our first test. The test is going to be conducted first week after the semester break. So I believe it's going to be week 8, right? All right, that's number one. The the questions of the test are going to be 20, multiple choice only. Okay, and it's going to be conducted through e-learning. Um, I think you are going to be given maybe 1 hour or thereabout, something like that, uh, for uh, for the question. These two questions actually comes from, let's say, a question bank. The e-learning, uh, what we do is we put more than 50 or 60 questions as going to be randomized. So each one of you will have a different question, but you are going to have the same time to you know, finish your test. And same goes to the final as well. But the question uh, total number is different. I think for the final is 40 or something like that. Okay, guys, everything clear for the test, the first test? Any question? Okay. Okay, good. So today we are going to discuss about computational thinking, CT. Anyone would like to tell me what is your understanding about CT? What is CT to you? What does it mean? Computational thinking.
Can I try?
Yeah, yeah, please go ahead.
So basically, computational thinking um, is about simplifying complex problem to to like smaller units of problems, so that we can provide so that we can get a solution for like the main problem. So it's actually um, we um, break down the problem, and then you solve it one by one. So starting from the big, so it's like from the big to small problems.
Yeah, that's lovely. Thank you very much. Okay, so computational thinking is actually we learn how machines or computers think. Okay, they don't actually literally think. They it's like their way of solving the problem that they have. And when we talk about problems regarding to machines or computers, everything for computers is a problem. Every order or every command for the computer is a problem. So they see everything that in a perspective of problem solving, you know. So whatever you give the computer or you command your computer is going to be considered as a problem,
Adik, awak ada kelas, dik.
and then they are going to
Ah,
look for a
ni kelas
way
sekarang.
to solve this problem. Please
Kau
mute.
tahu mah hari tu, bulan
Please.
10 hari tu, cikgu dia mesej.
Z,
Ali, awak ada
please
kelas pukul
off your
3.
mic.
Adik reply, okey. Lepas tu adik tak angkat call cikgu. Cikgu tanya, awak ni nak belajar ke tak?
Okay. All right. So, as I was saying, it's computation thinking or CT is a way of solving problem to the machine. So what we are trying to do as a human, we are trying to learn the same strategy. We are trying to solve the problems that we face based on computational perspective, which is breaking down the main problem into smaller, problems or complications, so that we actually solve each one in particular. So in total, it's going to be solve the main problem, right? Good. Okay, so it's an approach to solving problems by breaking the problems into smaller chunks and then working on them individually. Okay, there are so many definitions, but what I want you to understand about computational thinking is how it goes through steps. Okay, and these steps or process of problem solving are very common, in each problem. So first, we need to understand what is the problem. We need to define the problem that we have. Okay, and then we need to analyze this problem. If we could analyze it on, you know, as many steps as we could, it would be better, right? So if we have, let's say, this crime scene, and all right, as many items or as many, let's say uh, let's say, okay, somebody help me, analyzing the problem into, more details, all right, more smaller problems. Okay, as many as we have smaller problems and solve each one aside is going to help us to solve the main problem. This is what I mean by the analysis of the problem. And then determine the criteria for any solution. Each one of the problems that we have created has its own solution. And then we propose this solution, we propose it, we test it, we, clarify if it's going to work, or otherwise we are going to propose another solution, evaluate and then select the solution, and then suggest the strategies to implement the solution. When this solution worked, okay, perfectly to solve this problem, we are going to generalize it then. And then these are the main key elements of computational thinking, or the key concepts. Okay, the most common, let's say, concepts of any computational thinking, which are decomposition, pattern recognition, abstraction, algorithms. Right? Let's go ahead and see one by one. What is decomposition to you guys? What is the definition of decomposition? Anyone would like to try? Anyone?
Hello, can I try?
Yes, please go ahead.
Decomposition, right?
Mm-hmm.
Decomposition is to break down a really big problem to smaller parts so we can solve each the smaller parts, and we can also do next step, which is pattern recognition. By breaking it to smaller parts, then we can see the problem more clearly.
That's good.
Okay.
That's good. So any computational thinking process, okay, it has these four concepts. As our friend said about decomposition, yes, it's correct. It's actually breaking down the main problem into smaller problems so that if we solve these small problems, we are actually on the way to solve the main problem that we have. This is called decomposition, and we will learn some example of that. Okay, and then comes the pattern recognition. Anyone? Pattern recognition.
Uh, can you hear me, Doctor?
Yes, I can.
So I think pattern recognition is like finding same problem within the finding the same problem so that it will help us to solve uh, a bigger problems to make sure that
That's lovely.
that is
Yes, that's
understood like that.
correct. Correct. The best way, you guys, to understand pattern recognition concept is um, when we actually grow up, okay, day by day, year by year, we actually try to imitate our parents, whether father or mother. Okay, what we do is we look from the same perspective that they used to look. When you become a father or a mother, you are going to solve the problem that you actually having at the moment. You look in your mind, what would my mother do, or what would my father do? This process is called pattern recognition. You are actually looking in your mind about something familiar and common in solving this problem, the same problem, with somebody some previous experience. So you are looking for similarities to solve the same problem. So you will look for somebody that you love or somebody that you have lived a long period with. So this is the perfect example that you could actually understand the meaning of pattern recognition. So it's simply looking for similarities among whatever experience that you have uh, to solve the same problem that you face and they used to actually face. Okay. Right. What about abstraction? Anyone?
Doctor, I think it's narrowing down the information, leaving all the unnecessary details about it.
That's lovely. Yes, that's correct. If you guys uh, about the first assignment that we had, the article, you will find in any academic writing, academic article, you will find something. The first part of the article is called abstract. What do we mean by abstract here? We simply mean that all the important points are highlighted in this abstract. Okay, so if you read this abstract, you will understand the whole thing, the whole paper, 20 or 15 pages. So what we mean by abstract is we focus on the important information, key points, key concepts of the whole article. It's not like only a summary. It's like an executive summary uh, of the whole thing. You know, just key points. So if you, but it's key points, but actually you need to clarify it as well. It's not enough to, you know, keep on summarizing it, so other people, when they read, they wouldn't understand, because it's your work. When it's your work, you would uh, summarize it in a way that you only can understand, or you could actually summarize it in a way where other people, if they read it, they could understand. So this is what we mean by abstraction. We avoid any unnecessary information when we do the abstract. Okay. And finally, we have algorithms. Anyone would like to try to define algorithms? Anyone?
Can I try, sir?
Yes, please go ahead. Go ahead. Hello.
You hello?
Yes.
It's like a flow of the solution. And
Okay.
show you step by step how to do it. That's all.
Okay, that's good. So it's like a step by step or flow or a diagram, flow chart, you know? It's like the step by step, a guideline how to solve any problem. Okay? So developing a step by step solution to the problem that we have. Now, this is the general definition of each of these concepts. Let's learn more in details information about these concepts. So when we say decomposition, the example that we have here is brushing our teeth. Now, this is actually something that we do every day, but we don't look at it like in a perspective of more details. We just go ahead and do, brush our teeth. But if you break down this problem that we have here into smaller steps, this is these are the questions that you are going to have. What's the problem? Which toothbrush, how long, how hard to, press, what toothpaste to use. All this question is called decomposition. And this is just an example, okay? And this is the other example there we have when we actually are entitled to solve, for example, a crime. We need evidence, we need, uh, let's say, cameras, if there's a camera, if there's a fingerprints, with any witnesses, all these kind of, smaller issues that are going to help us to solve the whole problem. Now, when we look to pattern recognition, as I mentioned, it's actually something that have been previously solved or treated by other people. So we kind of look for the same treatment, okay, pattern recognition. Um, this is actually another example of pattern recognition. We see cats, all cats have the same, let's say, components or items, okay, that they are actually consist of, let's say, eyes, tails, and fur. So when we try to, let's say, draw a cat, we will make sure to draw these three main elements of any cat. This is what we call pattern recognition. So it's something that actually common on all cats. Okay. Okay. Now we have abstraction. As we mentioned, this is actually something about the main information or main the key points. So we are trying to avoid anything that is irrelevant to our issue, our problem. Okay. And then finally we have the algorithm. Algorithm is something more like, solving a problem. We go step by step, and then each step that we are going to take is going to lead us to the next step actually. Let's take an example. Okay, when you go to, for example, order some food, okay, you will start your order, and then uh, the employee is going to ask you actually, would you like a drink? If you say yes, he will ask you more questions. What type of drink? Let's say you have actually uh, said, okay, soda, all right? And then he will ask you, would you like some ice or no ice? Okay, so each question you ask, you will get more classifications. So if you answer no, simply it's going to end the question. If you answer yes, this yes is going to lead for more questions. This is what I mean by algorithms. Okay, so now what I want from you, I just want uh, one student to give me an example for decomposition, and one for abstraction, one for pattern recognition, and then one for algorithm, and explain it. So just give me an example and explain it. Okay, who would like to start? And please, guys, take note that I actually write down the names that for the ones who are active in the class, so that I could give some bonus, marks at the end of the course. This is what I usually do, and this goes to e-learning activity as well, the 10 marks. Okay, so try to be active during the class. That's why I record our meetings as well. Okay, so anyone would like to give me an example for decomposition and then explain it, like step.
Hello, doctor.
Yeah.
Can I give the example for decomposition?
Yes, please. What's your name?
My name is Muhammad Shafiq, doctor.
Shafi. Okay, go ahead.
Okay, from my understanding, decomposition is actually breaking down things that, for example, eating. When we are eating, we don't think much about it because it is in our subconscious mind. So when we break it down, it will be for us to sit down on the chair and to recite the prayers, the dua first, then which hand are we going to use, and which part of the course are we going to take first, whether it's the rice or the vegetables. Then how are we going to end it with, maybe we want to have the drink when we are eating, or maybe after eating. Then how are we going to finish it off?
That's good. That's good. That's lovely. You made us hungry. Okay. Thank you.
Thank you, doctor.
Thank you. All right. Next, let's take an example for what? Pattern recognition. Anyone?
Uh, hello, sir.
Yes. Hi.
Uh, for me, pattern recognition is finding the common characteristic of a certain situation. For example, when you want to, for example, a man is trapped in in a large island. So what he need to do is he have to find food. He have to find water, right? So one way is he need to find water, purify the water. So he needs fire. So in night, in the island, he need to have light. So he need to have fire as well. So that is the common characteristic. So he really need fire to survive in the island. So that is the pattern recognition.
Okay, that's good. But he needs more details. He need to know how to actually create the
Yeah.
fire. So maybe he need to watch Castaway movie. All right, that's good.
Doctor,
Yep.
can I talk about the abstraction?
Yes, please go ahead. What's your
Yeah.
okay?
My name
Sorry,
is
sorry. Let me ask the
sorry.
our previous friend. What's your name?
Muhammad Arif Irfan.
Arif. Okay, go ahead. Go ahead for the abstraction.
My name is Lo Payan, and I want to talk about the abstraction. In my opinion, abstraction it displays only the common things of the object and hide the unnecessary detail. Like when we are driving a car, we only care like how to start or stop the car, or accelerate, or give a brake to the car. We are not too care about how the start or stop or the accelerate mechanism or the process that work internally. So if in the computer science, we need to concern about the common things, which is the big picture of our program, because for the users, they are more interested in knowing the common detail and not the details that we do in our program, like coding and others. This is my opinion.
That's lovely. Thank you very much. Oh, that's correct. So abstraction is more about.
Thank you, doctor.
Thank you. Abstraction is more about focusing about whatever very very necessary information that we actually need at the moment to solve the problem that we have. Okay, this is what we mean by abstraction. So first we go with decomposition, breaking down the problems into smaller ones. Pattern recognition, we look in our minds for common solutions that we already have, okay, other people that already used to solve the same problem. And then thirdly, abstraction, we remove any irrelevant information that actually is not going to serve us solve the problem that we are facing at the moment. Okay, what about algorithms?
Hello, doctor. Can I try for the algorithm?
Yeah, please. What's your name?
When neural idea.
Okay, go ahead.
Okay, for algorithm, I understand that after we ignore the unnecessary things in the abstraction, we need to develop the steps by steps to lead into the classification, into the specific classification. So just like we wash our clothes using the washing machine, we need to sort out the dirty clothes first by dividing them into two, maybe the dark and light clothes. So after that, we what to say yeah, we put the clothes into the washing machine and maybe put the bleach for the light color clothes first before we wash the dark clothes. So after that, we add the detergent and we set the temperature. It means we do it by steps. We set the temperature and yeah, of course, the time of the machine according to the requirement of the clothes. And after that, we add the fabric softener and set the rinsing cycle. So and then if the washing machine is automatic, we just turn on the switch on. And after that, the clothes will be fully washed, and it means the last step. So yeah,
Thank you very much, Adia.
is it correct, Doctor?
Yeah, that's correct. So it's more about
Sorry, I'm lagging.
no. You don't need to do that. It's okay. It's more about following a step by step to solve any problem. Now, if in the way of um, this strategy, you will find some decisions or some issues that are going to require more details. It's actually more about yes or no. Okay, if yes, then you are going to be asked more question to give more details. Okay, if no, that means it's actually the end. But if yes, you will have to answer more questions to give more details until you actually um, find the no, until you find the no. So it's going to be asked more questions, more details until it's a no. The no is the end of the chart or the algorithms. Okay, it's more about a guideline or something like that. Okay, guys.
Okay,
So
so Doctor. So maybe maybe we ask our mother like do we have to put the pledge? So if the mother say yes, so the step is continue, right?
yeah, if the answer is yes, then you are going to ask more question. Okay, how much should I put? Okay, and then if she said, okay, you're gonna put just like that, and then okay, that's enough. You are going to ask her again. If she said yes, it's enough, then that's the end of the question or the end of the order. Okay,
Doctor, thank you.
thanks. Okay, guys, do you have any question? So you already, all of you done with the presentation, the video?
Yes, doctor.
Yes, Doctor.
That's lovely. I've seen some of the videos. They are very, very good. I like it. Okay, guys. Uh, do you actually have more questions? Any question in this subject?
Doctor,
Yeah.
uh, does YouTube algorithm has anything to do with real algorithm? Thank you.
Sorry, can you ask again?
Um, do you YouTube always use the word algorithm whenever they put like an old video sometimes? Why do they use the word algorithm?
Okay, algorithm is like a systematic way when we talk about a machine language. It's actually give more specific information. Let's say not only YouTube, all social media actually follow algorithms to define you as a consumer. Okay, let's say now when you talk with your friend about any kind of product, let's say it's like makeup or something, you will notice that the same day you will find some advertisements on Facebook or YouTube about the product that you actually have talked about. This is kind of algorithms that YouTube and Facebook follow to actually track the customer's behavior. They actually knew about what you are interesting about, and then they actually display it in your social media. Yeah, all social media, all social media, and this is something Mark, the Facebook founder, has actually gone through when he went to. Um, he was actually faced with many charges about privacy of people and so on, And what he said is that he said that we actually follow algorithms. We are not spying on people. So the machine actually hear whatever you say, whatever words, whatever brands or names, and then they follow one algorithm systematic way to match whatever you say with whatever data this social media has, and then they will actually give you the advertisements. So it's not spying. There are no humans listening to us. Okay, they are actually matching whatever keywords they listen, and they give you the product or the service. This is the meaning of algorithms that they follow. So what the machine actually goes through is that when they listen, for example, lipstick or whatever makeup product, there is a keyword. This keyword, when they actually listen to it, they will analyze billions of words that they have, and then they will choose the match, the image or the advertisements that they have. Then they will show it to you as a consumer. I don't know if it's clear to you, but this is the meaning of algorithms and how does it work on social media.
Yes, thank you, doctor.
Thank you very much. Okay, do we have any more questions? All clear,
Sir,
guys? Yeah.
Oh, sorry, can you go first?
thank you. Sir, you mentioned before in the WhatsApp, if we don't submit the video, we have to present in the class. Am I correct?
Yes, but anyone haven't submitted the video?
I didn't submit the video because I thought I can do it in the class, the presentation in the class.
Okay, anyone else or only you?
I'm not sure.
Okay, let's
Is there
listen.
anyone else?
Guys, is there anyone else who actually did not submit the presentation? Okay, good. Are you ready to go now for the presentation?
Yes.
Okay, let's hear from your friend first, and then we will get back to you.
Okay. Let me just open
All right.
the PowerPoint.
Okay, go ahead. Whoever who wants to ask a question before.
No, no, it's okay. I already found the answer. Thank you, doctor,
Okay,
about that question just now.
okay. Okay, Shkeen, right? Ashkeen, go ahead. Is it Ashkeen?
Yes. Can you give me like 2 minutes?
Yes, please. Take your time.
Thank you.
Okay.
Um, yes, May. We actually using computational thinking in a way or another, all right? But we don't actually realize it because we used to it, you know, we are used to it. But when we actually aware of the process of how to, for example, do the decomposition or pattern recognition, uh, this is simplify the concept of us of how actually computer think or how computers actually has the ability to solve the problems because sometimes uh, let's say you're actually using your computer to use a calculator, very very simple task, but in the computer world it's actually very complicated, so many commands and so many, you know, coding process to do that. Okay, so it's actually very common and very simple, but it has a lot of work behind it. Same goes to us as a human. When we actually used to brush our teeth every day, we are not thinking of the way how to do it, or there are actually steps to follow, you know. But what we need to be aware of, we need to understand so that we actually know how computer think, how computers solve the problems. And then we need to teach our children as well so that they will be more organized, you know, they will be more statics or systematic when solving the problems that they face. Does that answer your question, May?
Sorry.
Yes. Yes.
Can I share my screen?
Yes, please go ahead.
Can everyone see the screen?
Yes, you can see.
May I start, sir?
Yeah, yes, go ahead. Go ahead. Go ahead.
Okay. So, Assalamualaikum and a very good day. So for today's presentation, for assignment one, executive summary, I chose an article titled "The Use of Educational Technology for Interactive Teaching in Lectures," specifying in the medical education. And so, seeing the trend from years ago, the lectures in the medical education has been conducted in one way, um, delivering of content, or we can say chalk and talk. And we see that the medical students, they feel overwhelmed, or they feel it's a lot to take with the large volume of knowledge and also the complex skills that they are required to learn. And on top of that, they have to keep up with the recent updates in the medical field. And now after the interactive learning is introduced and it is practiced in lectures in the medical education. Although it is an improvement from the one-way delivering content, but we can see that it can be seen that interactive learning is a bit difficult to conduct when dealing with a big number of students in one lecture at one time. For example, they use questions and answer in class. So trying to get the students to participate and ask questions if they don't understand at any point of the lecture. And so we see that there is a need to improve the learning method in lectures. So this article, that I based on, aims to review the role of lectures in medical education and also the introduction of educational technology to enhance learning in lectures. So as we see, they use in the article, they mention two most discussed learning theory, which is the cognitive learning theory and also constructivism learning theory. I believe all of us have heard this in multimedia design lecture about this learning theory. So cognitive learning theory mentioned is mostly discussing to provide demonstrations, stimulate mental processing of information, and also give detailed real-world scenarios, which can help in deeper thinking and learning of students. Meanwhile, looking at constructivism learning theory, it offers students advice, guidance, and inspiration, while the students participate actively in self-directed learning to enhance delivering core knowledge and also explain difficult concepts. So why is actually we incorporate technology in education, especially in medical education? It is to help in storage materials and in efficient communication and also portability of teaching objects, as well as it is cost efficiency and it can be used, the application can be used widely, and it is time saving as well. So there are a few examples mentioned in the article about the use of educational technology tools in the medical education. So these are some. There were a few more. One of it is web conferencing or webinars, and also simulation in training, when they do simulation, maybe during, for example, surgery or stitches, video lecture, capture technology, podcasting, which is an audio file sharing via web. We've heard about podcasting, for example. Nowadays we can listen to it on Spotify, for example. And multimedia. Multimedia includes includes videos and also animation to help explain concepts in medical education. And also they use incorporate polling and quiz platforms, for example, that we know now can be Kahoot and quizzes to get the students to actively participate in lectures, and also they can see how much the students understand along the lectures. So even though we can see a lot of benefits of using or incorporating educational technology tools in lectures, there are also some, maybe a bit of disadvantages of it. For example, rewards for mastery. So the students are only focusing on the rewards when they are able to master or get the hang of maybe a topic. So they are only focusing on the rewards. And also lack of efforts, because everything is already given to them. Everything is given one by one through different resources. So it may seem like they don't put an effort to find for themselves because it's already given. And also poor learning from failure. Students may not see that by failing they can learn something, but it is only focusing on the they feel they can't understand the topic probably, and not trying to learn what they can the lesson that they can get from the activities in the lectures. And the author also mentions of the future recommendations. When we have been putting a lot of resources using educational technology tools, the next step is to focus more on the process of teaching and learning. And what does it mean by it is that more into supervising and also getting better feedback from the students. And also we for future we can promote more high interactive and independency driven educational activities. It is more on the students to drive themselves to get the knowledge or to find the knowledge rather than just accepting what resources that has been given to them. And so from this article, they've concluded, the author conclude that there is a need of more collaborative and continuous efforts so we can get or create appropriate technology tools for efficient education based on the educational theories. So there is a lot more potential in this field, in this area for medical education, and there's a lot more tools probably, and like the recommendation before, maybe focusing more on the teaching and learning process. So that is all from me.
Thank you
you.
very much, Ashkin.
I don't
That's a
get
lovely
any
way of
questions, sir.
presenting the article. It's very understandable. Okay, so they were actually looking for the role of lecturer in using technology in medical education, and the article was based on two theories, which is cognitive and constructivism. They have gave us some example disadvantages, which is very lovely, and yet you still need to upload the summary, the Word file to
I
eLearning.
did.
Okay, that's good. So anybody else haven't submitted the video presentation I would like to present? All of you have submitted the video. Okay, that's good. Thank you very much, Ashkin. That was a very good
You're
presentation.
welcome. Thank you, sir.
Okay, guys, that's all for today. I hope the computational thinking topic is easy for you. If you do have any questions, please go ahead. I don't know. Yuvan, are you here yet? Yuvan, are you here? Okay, he's not here yet. I'll just make sure to tell him about the test announcement. That's all for today, guys. Thank you very much for attending, and I'll see you next week.
Thank you, sir.
Thank you, guys.
Thank you, Doctor.
Doctor.
Thank you,
Thank
doctor.
you, sir.
Thanks,
Thank you,
guys.
Doctor.
Thank you,
Thank
doctor.
you, doctor.